Chapter 6, Section 5 is about point-slope form of a line. So by the end of this lesson, you should be able to graph and write linear equations in point-slope form, and then you should be able to write a linear equation using data. So point-slope form is exactly that. It's another form of an equation that gives you two pieces of information, a point and a slope. So we can derive this or figure out where it comes from if we use the definition of slope. So remember, the definition of slope says that m equals y2 minus y1 divided by x2 minus x1. And then they give us a little bit of information. So let's say that we know a line passes through this point, 3, 4, and has a slope of 2. If we plug that stuff in, we'll make this x1 and y1. If we plug it into the slope formula, we get this. And then all the slope formula, or the point slope form does, is get y by itself. So what we're going to do is multiply both sides by what's on the bottom here, this x minus 3. And when we do that, those cross off, and we end up with this equation right here. This is in point-slope form, because hidden in here, we have our two pieces of information. We have our slope of 2, and then we have our point, 3, 4. So this is kind of weird when you look at it. Your slope is really easy to figure out. It's whatever number is in front of the parentheses there. But then this number here is your y coordinate, because it's hanging out with y, and this right here is your x coordinate, because it's hanging out with x. Now another weird thing is, remember, we subtract here. So our point wasn't negative 3, negative 4, it was positive 3 and positive 4. So just these numbers here are your x and y coordinates. So here is our definition. Point-slope form is when a line passes through the point x1, y1, and has a slope of m. So this part right here, you plug in the y of your point. This part here, you plug in the x of your point. And then this is always your slope. Now these other x's and y's are just like in our other two forms where we have an x and a y. And I put the other two forms on here so we can kind of compare them. Remember, slope-intercept form gives you two pieces of information, a slope and the y-intercept. And then standard form doesn't give you any information, it just makes it really easy to find your x-intercepts and your y-intercepts. So let's say I give you this equation and I tell you to graph it. You can do this two different ways. The first way is you could just convert into y equals mx plus b, which means get y all by itself and get rid of the parentheses. So let's do that first. If I have this equation here, the first thing I want to do is get rid of these parentheses. So I'm going to distribute this negative 2/3 to both of these things here. So I get y minus 5 equals negative 2/3 x. And negative 2/3 times 2 gives me negative 4/3. And then I got one last thing to do to get y by itself. I want to add 5 to both sides. So we get y equals negative 2/3 x. And then if I want to add this, 4/3 and 5, remember we can write 5 as 15/3, give it the same denominator, but 15 divided by 3 simplifies to 5. So if I subtract these, we end up with 11/3. And 11/3 is almost 4, so when we go to graph this, we want plus 11/3. And if you want to, you can convert this to a mixed number. 3 goes into 11 3 times with 2 left over. So then when we go to graph this, we're going to go up 11/3, which was up 3 and a little bit. And then we're going to find our slope. So down 1, 2 over 1, 2, 3. Down 1, 2 over 1, 2, 3. Remember, you can make as many of these as you want. And there we go. Now the other way that you can do this is to use this point-slope form. Let's get this stuff out of the way. Use y minus y1 equals m times x minus x1. So this tells us two pieces of information that we need. First thing, the easiest thing to figure out is our slope. Just by looking at this, I know my slope is negative 2/3. Now remember, the other thing that this gives us is a point. It gives us an x value and a y value. And if you think back to this form, it's always opposite of whatever's right here. So if it's x minus 3 in parentheses here, the x in my point is positive 3. If it's x plus 3, then in my point, that would mean I have a negative 3. So always opposite. So when we look here, because this is a positive 2, remember we could really write this as x minus a negative 2. So the x in my point is negative 2, and the y in my point is 5. So just like this last one, I can find this point, negative 2, 5. If you look, that's on the line that we drew before. And then use slope. So down 1, 2, over 1, 2, 3, and that point's on the line that I drew as well. So it doesn't really matter which one you want to choose. This one, the converting part was a little messy because we had this fraction here. This one was a little easier, but if you forget to change these points to their opposites, that will cause your line to not look correct. So the other types of problems you're going to get for this section give you just bits and pieces of information, and you have to come up with an equation. So write the equation of a line that has a slope of 2/5 and passes through the point 10, negative 8. So this gives you two pieces of information. It tells you a slope and it tells you a point. So let's use point-slope form. Now let's write it up here. Remember, the more you write it, the better it will stick in your head. So write it down every chance you get. So then let's plug stuff in. I have y minus the y in my point. So I come up here, the y in my point is a negative 8. And that equals the slope, which is 2/5, times x minus the x in my point, which is 10. So I have y plus 8 equals 2/5 times x minus 10. Now sometimes it'll just ask you to leave it in point-slope form, and if it does, we're done. But we're going to go one step further, and we're going to convert it to slope-intercept form. And remember, slope-intercept form is y equals mx plus b. So the two things that are different from point-slope and slope-intercept are y is by itself, and there's no parentheses. So just like we did before, that's what we got to do to get rid of this. So the first thing I'm going to do is distribute again. So I get y plus 8 equals 2/5 times x. And then this one's a little easier. If I do 2/5 times a negative 10, I end up with negative 20 on the top, divided by 5 on the bottom, which just gives me a negative 4. And then all I have to do to get y alone is subtract 8. So I get y equals 2/5 x minus 12. And just like before, if I graph this one here or the one over here in the light blue box, they're going to be exactly the same line. They're just written in different forms. I want you guys to pause the video and try doing this one on your own right now. Alright, so the point-slope form, when you plug it in, you should end up with this first equation here. And then after you do a little algebra and simplify it, you should end up with y equals negative 3x plus 4. Make sure you ask me a question if you don't get this. So now let's use 2 points to write an equation. So remember back here, point-slope form says that I need two things. I need a point and a slope in order to plug stuff in. So we're going to do some problems sometimes where they just give us 2 points. But remember, with 2 points, we can use that to find the slope. So if I give you this equation here, 2, 3 and negative 1, negative 5, the first thing I want to do is find the slope so that I can plug it into y minus y1 equals m times x minus x1. So remember, slope is y2 minus y1 over x2 minus x1. And let's make this point 1 and this point 2. So I have negative 5 minus 3 on the top, divided by negative 1 minus 2 on the bottom. So on the top I get a negative 8, and on the bottom I get negative 3. So this simplifies to 8/3. So now I have a slope. I know the slope of this line is 8/3. And if I want to plug it into this equation right here, I only need one of the points. And the awesome thing is, it doesn't matter what point you pick. Let's pick this first one up here, because it doesn't have any negatives. That'll make your life a little easier. So if I do y minus the y in my point, which is 3, equals the slope I just found, times x minus the x in my point. This is in point-slope form. We can leave it like this, but it told us to write it in slope-intercept form. So all we have to do is what we've been doing the last couple problems. First thing we should do is distribute. So y minus 3 equals 8/3 x. And remember, if you do 8/3 times a negative 2, you multiply what's on the top and on the bottom and simplify if you can. And in this case we can't, so we're just going to leave it. And then the last thing we got to do is add 3 to both sides. Add 3, add 3. So we get y equals 8/3 x. If you take negative 16/3 and add 3, remember 3 is really 9/3. So when we add what's on the top, we end up with a negative 7 divided by 3. And there is our equation. Part 2, writing equations using data. So we can write a linear equation to model data in tables. Two sets of data have a linear relationship if the rate of change between consecutive pairs of data is the same. For that data to have a linear relationship, the rate of change is the slope. So is the relationship shown by the data at the right linear? If so, model it with an equation. So what we want to do is we want to find the difference between our x's and y's and then compare the ratio of them. So how do I go from negative 7 to negative 3? I add 4. And then how do I go from negative 11 to negative 1? I'm going to add 10. And then remember, slope is change in y divided by change in x. So my change in y is 4 divided by my change in x, which is 10, and that reduces to 2/5. So we need to do that with all of the points on this data table to make sure that this relationship is linear. So let's do it with the next one. Negative 3 to negative 1, all I have to do is add 2. And negative 1 to 4, all I have to do is add 5. Now it doesn't matter that these two numbers aren't the same, but if I find the change in y divided by change in x, I get the same thing that we got up there. So we got to do it with the last one. If I go from negative 1 to 5, that means I'm going to add 6. And if I go from 4 to 19, I'm going to add 15. So if I do change in y divided by change in x again, 6/15 can simplify down to 2/5 because 3 goes into both of those. So I got 2/5 for all of my rates of change. That means that this is linear, and it means that my slope is 2/5. And then if we want to model this with an equation, we have a slope, and all of these things here are just points. So we can plug these into point-slope form. Y minus y1 equals m times x minus x1. And just like before, it doesn't matter what point you pick. So pick your favorite one. I'm going to pick 4 and negative 1. So you do y minus the y in your point, which is a negative 1, equals the slope we just found, which is 2/5, times x minus the x in my point. And you can simplify this first part to get y plus 1 equals 2/5 times x minus 4. You can leave it like this if it doesn't say to do anything different, but if it asks you to write it in y equals mx plus b, then you would have to convert it. So, can you graph and write linear equations in point-slope form? You have 2 where I give you just 2 points. And then, can you write a linear equation using data? So, same type of question as before. Is this linear? It is. But then tell me why and model it with an equation. Make sure you write down any questions you have and ask them in class. Have a good night.